Welcome to another instructional video from OWL, the wise choice in fiber optic test equipment. I'm Professor Jim Powers. A common misconception in the fiber optics testing industry concerns the use of interchangeable connectors on test equipment, particularly fiber optic light sources. In other words, changing the connector port on test equipment to accommodate a different connector style. Having interchangeable connectors for fiber optic test equipment might seem advantageous. In reality, using interchangeable connectors on test equipment actually encourages poor network design and testing practices, contributes to unnecessary cost and maintenance issues, and adversely affects important government calibration of light sources. This video will cover the misconception behind interchangeable connectors, show some reasons why interchangeable connectors are not necessary for fiber optic test equipment, as well as explain why interchangeable connectors should be avoided at all costs for fiber optic light sources. Before continuing, it is important to understand the key differences between receiving equipment, in other words, detectors, and transmitting equipment, in other words, sources. This issue is connector alignment. Detectors, which are used in optical power meters, must be very large in relation to a fiber core in order to fully accept the light exiting the installed fiber link, regardless of fiber type. Thus, a connector port could be slightly misaligned or could even shift a little bit in the detector port, and this would not affect the optical power readings at all. This is why it does not matter whether or not an optical power meter uses interchangeable connectors. In fact, all optical power meters utilize interchangeable universal connectors, one for 2.5 millimeter ferrule connectors such as ST, SC, and FC, and another for 1.25 millimeter ferrules such as LC, MU, and other small form factor connectors. Sources, on the other hand, are very sensitive to connector alignment for two reasons. First, the core of an optical fiber is very small, so the fiber core must be aligned as perfectly as possible with the output of the source in order to ensure optimum coupling of optical power into the optical fiber. Second, once a connector is inserted into a port, the connector must not be allowed to move, especially after a light source has been zeroed. Otherwise, the optical power measurement could vary greatly. Because of this, the main focus of this video mainly concerns interchangeable connectors on light sources. The main reason why interchangeable connectors have found a niche in the fiber test industry is that there are many different connector styles to choose from. However, there are many fiber optics professionals, especially beginners, who may not realize that there are no distinct advantages to changing the connector style of test equipment ports. In fact, connecting an installed optical fiber directly to test equipment goes against best practice for two key reasons. First, the fragile nature of optical fibers, and second, proper fiber optic test procedures. Okay, optical fibers such as this one typically contain multiple buffered optical fibers. An outer cabling jacket and other protective materials such as aramid yarn ensure that the fragile buffered optical fibers inside are sufficiently protected from external forces while they're inside the main cable assembly. So as you can see, there's again this outer jacket. We have this aramid yarn that's designed to protect the fibers, and as you can see, there are actually 4 optical fibers in this link: an orange, a green, a blue, and a brown. Now, as you can tell, this protective cable jacket and aramid yarn must be removed in order to connectorize each of these individual optical fibers in this cable. But as you can probably guess, doing so exposes the fragile optical fibers to the environment where they are more vulnerable to damaging effects. Now, I have another cable here that's demonstrating that fact. So you can see that this cable, the cable jacket's been removed, the connectors have been put on, but as you can tell, if you want to connect this fiber into like say a piece of test equipment like this wave tester power meter here, I would simply plug the connector right into the port. Okay. Now, what you can tell here is that, well, this fiber is very fragile in its current state. If I move this power meter wrong, I could break that fiber. Likewise, if I'm taking this same fiber and I have to plug it into a plug it into a switch port or a hub port or a router or something, and the port is on the front of the piece of active equipment, well, anybody could walk by and bump this fiber and break it. So it is extremely poor network design to allow the fragile buffered fibers to be connected directly to any equipment, whether it be active equipment or test equipment. Instead, proper fiber network installation should always include a way to protect the fragile fibers. Typically, this involves patch panels or other types of protective enclosures. These enclosures typically include a protective tray where fragile optical fibers can be managed as well as protected from the outside world. So, for example, I have a little splice tray here. As you can see, there is a way to manage these fibers. You bring the fiber cable in, and you can wrap it around this little area here that manages the fiber nicely. And you can take these fibers and you simply plug them into the back of the patch panel here. So I'll just plug these in quickly here. And then once we're done connectorizing here, what we usually do, once they're plugged in the back here, usually there's a cover or such that you can put over the top of these. Now, as you can see, the fibers are protected from the outside world now. Once the fibers are connected into the back of this patch panel, the way to make the connection into the fiber link is through the use of a ruggedized patch cable like this one. Patch cables are designed to be handled so that they don't break very easily. So you basically just plug this cable into the front of the patch panel, and then you use this patch cable to make the connection to your test equipment, or, for example, or if you're plugging it into a switch port or hub or router or something like that, you just plug this end into the equipment to make the connection. The whole purpose of testing an optical fiber link is to measure the insertion loss, or attenuation, of the fiber under test. Optical loss measurement is important because it is an indication of the quality of the installed fiber link. Which brings us to important concept number 2. It is impossible to measure the insertion loss of an installed fiber link simply by connecting the installed fiber link directly to test equipment. Here's why. Measuring insertion loss actually requires 2 separate measurements. A measurement of optical power before the light has traveled through the fiber, and another measurement of optical power after it has traveled through the fiber. The difference between these 2 optical power levels is the insertion loss of the fiber under test. Obviously, if the installed fiber link is already connected to the test equipment, there is no way to know what the optical power level was before the light traveled through the fiber. This is why every insertion loss measurement requires the test equipment to be connected together through one or more patch cables, depending upon the actual link configuration. This process is called setting an optical reference and is also sometimes referred to as zeroing. Once the reference is set, the installed fiber link is inserted between the reference patch cables in order to take the final end-to-end measurement, hence the term insertion loss. Since the link is installed correctly between 2 patch panels, simply plug the reference cables into the patch panels. Now we come to important concept number 3. Patch cables can be configured with any combination of connectors, so it is not necessary to match the equipment port and the patch panel port. In other words, any equipment, whether it be test equipment or active equipment, can be connected to any patch panel simply by having the right patch cable with the correct connector combination. So, for example, if the equipment port is SC like this one is, but the patch panel is ST like this, then all you would need is a hybrid SC to ST patch cable. As you can see, there's SC on one end, ST on another, and this will provide the connection between the 2 testers. And I'll connect into the network just to demonstrate this. So, as we can see, due to the fragile nature of optical fibers, as well as proper optical loss test procedure, it is always best practice to install patch panels and use patch cables to make the connection between the equipment and the installed fiber link. Interchangeable connectors are quite expensive to purchase, especially considering that there are many different connector types that exist on the market. In other words, you would have to purchase one adapter for every one of the different connector types you want to use. Maintenance of these adapters can also be difficult since the adapters are typically small and thus easy to lose. The cost savings of avoiding interchangeable connectors would be put to better use towards the purchase of patch cables, which, as we have already seen, are a necessary requirement for proper testing of installed fiber links. Finally, calibration is another key reason interchangeable connectors should be avoided, specifically for light sources, since light source connector alignment is such a key issue. Standards-based, government traceable calibration, and in the U.S. this is done by the National Institute of Standards and Technology, or NIST. This is perhaps the most important aspect of a light source's accuracy. If the alignment or connection of the light source port is disturbed in any way, such as with changing out an interchangeable connector, the light source is no longer in its original calibration condition. When this happens, any sort of government traceability the light source once had will be lost. Thus, to make absolutely sure proper calibration is maintained, light sources should have fixed, non-removable connector ports. Some test equipment manufacturers offer interchangeable connectors for their test equipment. As we have seen, due to the sheer size of photodetectors used in optical power meters, interchangeable connectors do not cause issues. However, for light sources in particular, there are several compelling reasons to avoid interchangeable connectors as much as possible, including the fragile nature of optical fibers, proper fiber optic test procedures, cost and maintenance issues, as well as issues related to government calibration. This has been another instructional video from OWL, the wise choice in fiber optic test equipment. For more instructional videos, or to learn more about OWL's products in general, please visit owl-inc.com. I'm Professor Jim Powers. Thanks for watching.